I'm going to take you back to about 400 million years ago, during the Silurian. I'll be talking about the Sangamon Arch in northwestern part of the Illinois Basin, which is surrounded by several arch and domes. During mid to late Silurian time, the Sangamon Arch existed in the northwestern part of the Illinois Basin, in the gently sloping ramp area of the basin. In the Sangamon Arch, oil production, commercial oil production, began in 1925 around Decatur, and several fields are discovered. Over 33 million barrels of oil have been produced from the upper part of the Silurian deposits. There had been no study on reservoir correlation and characterization, and as you know, these are very important for petroleum exploration and enhanced recovery, and that was why I started working on this project. I'll be talking about the occurrence, distribution, phases, and controls within the Middle Silurian racine formation of the Mount Auburn trend in the Sangamon Arch area. The Mount Auburn trend parallels the Sangamon Arch trend and includes a few oil fields in Macon and Christian counties. In this area, rocks of the Silurian racine formation are composed mainly of dolomite and limestone and are overlain with a distinct erosional nonconformity by the upper Devonian New Albany shale deposits. The Silurian racine formation consists of two different sequences composed of characteristic deepening and shallowing upward packages superimposed by several small-scale shallowing upward cycles. Working in the subsurface and with well-to-well correlation, I found an erosional unconformity between the two sequences. This erosional unconformity removed part of the upper part of the lower sequence. In some locations, over 60 feet of the upper part of the lower sequence has been removed as a result of erosion at the sequence boundary. The reservoirs are interlayered with laterally continuous impermeable limestone and occur in the upper part of each sequence in this area. The reservoirs are laterally discontinuous as a result of erosion at the sequence boundary and also because of the lateral phases changes in the formation. Each reservoir occurs in the upper part of a shallowing upward cycle, and it is capped by a tight, impermeable, sometimes silicified limestone. The capping limestone facies includes bioclast of open marine environment, and the reservoirs are dolomite, and they are as a result of dolomitization of reef or non-reef facies, which could include molds or relics of bioclast of the original limestone. Dolomitization and formation of the voids and dolomite crystals occurred right after deposition as a result of dissolution of the limestone and formation of dolomite in the previously deposited sediment. In the restricted marine environment, a slightly higher salinity, seawater, with higher magnesium to calcium ratio could have percolated through the sediment previously deposited, and dolomite could have formed in this way. In this process, the dolomite near the restricted environment would include entirely of dolomite crystals and voids. But going downward in the sediment and basinward, the dolomite would change to bioclastic dolomite with voids, and finally to a limestone, impermeable limestone, containing open marine fossils, and you see here the bioclast of Prairie and trilobite showing open marine facies. During the translation, the open marine facies would cover the reservoir that already formed, and a new cycle would start Thank you.